now we're in what we call the crash lab. In here we have our crash sled and also our large 900-ton press, which is where we form a lot of the components that we do in this research group.
So the research activity here is sort of starting with manufacturing, lightweighting products, stamping operations, that kind of thing, all the way through crash worthiness. So we actually are the only laboratory in North America, one of the few in the world in fact, that actually has deep infrastructure for accomplishing that type of research.
Well, the crash sled facility at the University of Waterloo is a very unique facility. It's used mainly for testing components so that they can absorb more energy and make the vehicle safer while using newer technologies to make the parts lighter. Everything we can do in the lab, we can pass that on to industry.
So whenever industry has an issue with a component that's not forming or a new operation they want to perhaps consider implementing, we'll do tryouts here, we'll do the simulations, virtual manufacturing, the whole 9 yards. More of a farm-to-table kind of lab environment here. One of the emerging fields within advanced manufacturing has been the use of hot stamping technology to form ultra high strength steels. These steels have strengths in excess of 1500 MPa, which is about 7 times stronger than you'd see just even 10 or 15 years ago within the vehicle structure.
So in this lab we have a combination of students, our research team, our technicians, our technologists.
We have lots of lab technicians, we have postdocs. I have 2 supervisors, and whenever you need help, you are given help, you can discuss. And they also give you the opportunity to actually look beyond your project. So there are so many opportunities, there will never be an end to learning.
We're also active in aerospace and in defense industries, and once again, it's particularly rewarding, and it's a real pleasure for our students to engage in these types of projects. Again, being industry-driven projects, they actually find that highly motivating.
So my research relates to characterizing aluminum or high-strength aluminum alloys. I do elevated temperature tensile tests and other tests that characterize material properties that can be used then to model the forming operation with the same alloys.
I chose the University of Waterloo for my PhD because of the competitive and open atmosphere, and also the autonomy and the well-known professors with research interests similar to mine.
I think that doing a master's program at the University of Waterloo was one of the best life choices I've ever made. I think I gained tons of valuable knowledge and experiences by being a master's student at this university.